Hey everybody, it is time to Kahoot. We'll start here in just a moment. I'll be displaying the code. I was waiting for the music to start back up. Thank you everyone in the chat for the positivity. Let me go in here. There we go. We can see everything going on. Good to see you here, Ryan, Alan, Joseph, Cullen, and Cody. Let's invite Mubot here. Mubot, where are you at, Mubot? Mubot is not here yet. Hey, what's up, Caleb? Hey, Cody. Good to see you. Everybody, Cam is here, Isaiah's here, Abby's here, Mubot. Where are you at, Mubot? Where are you at? Mubot. Mubot is here, I believe. Mubot, are you here in the chat? Mubot, can you hear me? Nervous, Stephen Farkut. No, don't be nervous for the Kahoot. Have your... Oh, I have no points. What am I doing? What's up, Justin? Good to have you here. David, Kelly, good to have you here. Haley, everybody... We're on a public stream, so who knows? Should be chill. So I'll get started here in just a moment. Let me display the code. Take down the UT Marvel. Which button is it? So really bring down. Oh, there we go. The code is out there. The code is out there. Brian, you are the point. So it's like, oh, that's awesome. I'm looking like purplish these days. Let me try this. Let me try to fix this. Brian is goddering. I do have a lot of points. Let me see here. Color saturation. Throughout the day, what's happening to me? No. You can change all the saturations and everything. So you can change all these. Yeah. Contrast. Oh my gosh. What have I done to my picture now? What have I done? What have I done? Brightness. Okay, is that better? What does everyone think? Better or worse? Lowered the brightness. Better, worse. Better, worse. No one has any opinion. It's small Brian.
Tiny Brian's voice.
Mega Brian's voice.
We'll go here to the cave. Let's head right over here. Where's the cave at? So really used. I've got so many things on here. Oh, here we go. Anything going on? What? I think this might look better. Oh yeah, we're back. Let's hop back here to space. Change the... It's chilling out. If you do your whole class in Tiny Brian's voice. I think it'd get pretty confusing. This will be recorded, so this will be recorded. I think this looks better. No one gave me any views on does this look better. It probably looks exactly the same. As I totally... Knobs are so sensitive. Turn them up, turn them down. Everything is straight. Where's Brawl at? I don't think there's any Brawl on this screen. Wait. I know where Brawl's at. Brawl's up here. So he's there. I'm gonna touch Brawl's elbow. I can't touch Brawl's elbow. So there we go. There's Brawl. What's up, Dan? So good to see you here. Joining the Kahoot. Brawl's blocking the code. Go away, Brawl. Go away, Brawl. I like purple, Brian. Oh my gosh. So I think what else I have on here that we haven't like... See, I've got so many different lights. This is what I do in my spare time is oh, wait a minute. I look less purple now. Sorry, purple Brian's gone. Now it's purple Brian. I'm still purple. I don't know what's going on. We'll start the Kahoot here in just a moment. Display looks good. A little pink tone, but nothing major. There we go. It's so hard. There's a bright light right here. You can see my hand right there. There's bright lights over there. You can't really see that. And then there's bright light over there. You can't see them. Can't see them. Watch this. Watch this. Behind the scenes look. A behind the scenes look. I need to start using this more often. You're right. Here's the behind the scenes look. And then we'll get started after this. Purple looks great on you though. Thank you. We'll hop over here. You ready? Go back over here. Camera's off. We need to do more with the board. We need to do more with the second camera. Oh, you couldn't hear me? Oh, shoot. Darn it. Sorry about that. I should be back now, right? Audio. Okay, we're good. Second microphone's on the ground. Maybe it's not taking audio right now. Okay, is everyone ready? We got our 5 minutes of fun in. Is everybody ready? 5 minutes of fun was had. Is it time for the Kahoot? What does everyone think? Is it Kahoot time? Get some I'm readies in the chat. Some I'm readies. I'm ready. See what Mubot has to say. I think it's about time here. I was just killing time. See how many points I do have. Some I'm readies. Let's do this. 13,000 points. Your name's Andrew too. Mubot, you're such a kidder. Let's get ready and let's start this Kahoot. Here we go. I might have to hop out of the way of some of these questions. State your conclusion about the QQ plot. State your conclusion about the QQ plot. So what does a QQ plot look at for us? What is the deal with a QQ plot? What's the deal with a QQ plot? Well, a QQ plot is going to analyze that there. It's going to analyze normality. So that's kind of a hint right there. Now, you might be thinking, wait a minute, that's a line. But that line right there in the middle, as Tiny Brian told us today, is whether or not it's normal. So when you look at this line right here going down here, if it follows it, it's normal. If it doesn't follow it, it's not normal. So the conclusion is it's normal. So does everyone understand why it's normal? Is that when we look at this QQ plot, we're asking, does it follow the normal distribution? So if you look at the very bottom down here, and I'll go back down there, at the very bottom of the screen, it says if it's normal. This is the distribution of the variable if it's normal. No, Timothy, no. So that's the distribution if it's normal, and it looks to be pretty normal right here. So the reason it looks to be pretty normal is it's following the distribution. Does that make sense? It's following the red line. So the red line is if it's normal and these points are following it. Now, if one point goes out of it, don't freak out. Who's in first? That's a really good question. We got 20 questions to go. Sorry if I move around the screens just because I might be blocking a question. They changed the way the questions are formatted. Maybe they changed it back. Brian is, I wish. I want to win that $20 gift card. $20 first place, $10 second place. It is Diplomat Fox. Very diplomatic of them. Diplomat Fox with Helpful Glider, Radiant Dragon, Epic Octopus, and Glad Wolf. I was going to say Waffle. Well, waffles. So we'll continue on here with the next question. Here we go. Compute the expected count for Verizon rarely. Ooh, compute the expected count for Verizon rarely. This is a question we did in class today. Someone's grabbing their calculator. You got your computer open, hit Command Spacebar on a Mac or hit your calculator on a computer. Have the calculator open. Oh, shoot. That might have blinked the screen. You might need a calculator. It's only a few where you need a calculator. I should have warned you. Click, quick, click, quick. Okay, let's see how to do it. You ready? What is the formula? Can someone put the formula in the chat? Can someone put in the formula in the chat for the expected count? Got that calculator, quick draw. Being prepared. It's like the test right now. What is the formula? What is the formula for the expected count? What is it? It should be row total times column total over grand total. Row total times column total over grand total. Exactly. Nice job, Andrew, right there. So we're going to do row total for Verizon. So that's 310 times column total for rarely, because that's what we're calculating, 437. And then we're going to divide by 579. I did round it up, I believe. So it's 234. Row total times column total over grand total. Row total times column total. Row total times column total over grand total. So that's something good to have on your formula sheet or just because you get a cheat sheet for the test. So definitely have that written down. Row total times column total over grand total and know how to solve it. So does everyone see how to get the expected count right here? So we've got the row total for Verizon is this. The column total for rarely is this. And divide by the grand total. I was really nice. I made sure that if you know the answer, you got it. It doesn't say round on the test, but I would just put in all the decimals. They all have margins of errors. So that way, if you put in a number, it's got enough of a leeway, but don't do any crazy rounding. Just if I were to take this, I would just copy it. So I would just type in 233.9723. I'd probably do it to 4 decimals, but truthfully, with my rounding on the test, you could put in 234 and it would accept this. But don't do any rounding till final answers, and put in enough decimals that you think you'll be fine. There's not going to be. I made sure the plus or minuses are very forgiving. Yep. Both classes have a cheat sheet, front, back. It can be written. It can be printed. Whatever you like. Cheat sheet, front, back. So that's got it. Good questions right there, Kelly. Good to have you here. Diplomat Fox, no. Okay. Epic Octopus. Great job there, Epic Octopus. Caring Octopus and Epic Octopus. Tag team duo, Octopus duo. Will they lead? We'll find out with the next question. True or false? Side-by-side box plots compare a categorical Y and a quantitative X. Side-by-side box plots. Ooh, a little tricky right here. That is correct, Cam, for the exam. Starts tonight at midnight, or tomorrow at midnight, and starts and ends. So it's a 48-hour period. All Wednesday, all Thursday. This is a mean question. I feel bad for writing this question. Someone's going to be like, no! Whoa, 50-50. No, unless people got it. What's wrong about this? Who wants to explain what's wrong about this? What is wrong about this? Because someone's like, wait, it's categorical quantitative. What's wrong about this? There's something wrong. It's not mosaic. Mosaic, yeah, Andrew got it. It's the X and the Y are switched. Categorical, it would be a categorical X and quantitative Ys. So it'd be, there we go, Joseph's got it, yeah. What would be categorical? It might be ruining some later questions. If you have categorical, I think Ryan says it's a mosaic plot. If you have quantitative, it would be a what? So quantitative would be a what? Quantitative is a what plot? You can do a QQ. Well, QQ plots are tests to see if it's, but those are to see if it's normal. Scatterplot. Histograms are only univariate quantitative. A histogram will be one variable. Histograms, you can do stacked histograms, which are categorical quantitative, but a singular histogram would be quantitative. 2 quantitative variables make a scatter plot. If the X variable is time related, it'd be a time plot. So awesome stuff right there. Let's continue. Is there anything for categorical Y and quantitative X? You'd be doing logistic regression, which we will get to. So logistic regression will predict a categorical Y and a quantitative X. That'd be logistic regression. So mosaic is categorical. That's correct, Cody. Yep. Mosaic is categorical. We'll probably see. What did I put? We kind of had that before a moment ago, because a contingency table is categorical. So we just did a contingency table a moment ago, and that's categorical, which was like +2. Ooh, the octopus is still in the lead. Both octopuses, Glad Wolf and Bold Griffin. Diplomat Fox is back. Diplomat Fox, good to have you back. No sadness. Next time Diplomat Fox leaves, very sad times. Let's do this. True or false? Scatterplots compare a quantitative Y and a quantitative X. True or false? We should know this one. Let's see what people say. Scatterplots. Quantitative. Or is that a QQ plot? QQ plots are used to judge normality. They're called normal quantile plots. So a QQ plot is normal quantile plot or normal probability plot. But those gauge normality. But when I say QQ, I might be talking about 2 quantitative variables. So if you're talking about 2 quantitative variables, you are talking about scatter plots. It should be behind me. Let me show the game pin. There we go. I'll just move over here. There's the game pin right there. Pause the screen. Make sure you get it, and make sure to be watching live. Make sure it says live. Maybe reload the stream sometimes. But if you're watching live, that's a good way of doing it. Nice job, Sam, right there on the points. And so there's the pin. And going on, I think everyone knows, well, not everyone, but I think everyone maybe understands 2 quantitative variables make a scatter plot. We're good on that. The octopuses are just running away with it. If octopuses can run. Diplomat Fox, 4th place. Love it. Keep Diplomat Fox. I don't know who you are, but I'm rooting for you. Diplomat Fox, you and me. We're in this. I am. Diplomat Fox. Let's do this. True or false? Histograms display a categorical variable. Boom, we should know this one. We should say, or What are we going to say? We're going to be like, yeah or no? What is it? It's a bunch of weird figures on it. A bunch of chemistry. This is under the math section, and it's got chemistry. I was like, well, it's a neat graphic. Sure, why not? The answer is most definitely... I'm giving away the answer right now. Histograms display one... Oh, no! 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 Oh, no! No, that's the wrong noise. What is going on? Kahoot over. Bye, everybody. Okay, we're back. All right, let's see where this is going. Okay. What is it? Histograms display a singular what? 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 A histogram displays one what? One quantitative. Histograms display one quantitative variable. Histograms display one quantitative variable. 50-50 on that. No! Have these written down. Have these written down. Timothy, you're cracking me up. Okay. Oh, no. We lost an octopus and we lost a fox. But we gained a badger and a dragon. Oh, my gosh. What is going on here? What is going on in the world today when you can't count on an octopus? Let's continue on. What is the best way to investigate normality? Do we look at a histogram? Do we look at a scatter plot? Do we look at a box plot or a QQ plot, which is a normal quantile plot? Now, we did look at one of these earlier, so review back. And remember, we did investigate normality, and you'll see the plot we were looking at. Now, we talked about this in class today, too, how some of these are bad, like histograms are not good ways of looking at them. One of these doesn't even work. Who knows, for 1,000 bonus points during this, one of these you can't even really investigate normality with. Which of these just doesn't even make sense? Sorry if you picked it, but one of these just doesn't make sense to investigate normality. The one that does not make sense to investigate normality at all would be the scatter plot. Nice job, Maxwell and Evan right there. The scatter plots. The scatter plot is a bivariate graphic. And don't worry if you picked it. It's all right. Maybe that was one of the quick picks right there. But the scatter plot is a bivariate display. And so you can't really look at the distribution of a univariate, like the normality of one variable. So the QQ plots, we looked at it earlier. Double check from earlier in the Kahoot. You will see a QQ plot. And we were trying to see if it was normal or not normal. How are our octopuses? They're doing fine. No one worry about them. What is it called? I can't think. What is it called when you get the fried octopus legs? So now I want that. I want sushi. What am I doing? Looking at octopus right here. Continuing on, the next question. Who's ready right here? Let's do this. Calamari. Damn you. If the relationship between two variables is monotonic and linear, which option should you pick? The relationship is monotonic and linear. The relationship is monotonic and linear. So monotonic means it goes in one direction. So it goes in one direction. Linear means a line well describes it. So if it's linear and monotonic, there's a right choice to pick right here. Now, this is the relationship between two quantitative variables. And so what would we be doing right here? Pearson. So when you compare two quantitative variables, if you're talking about the strength of the relationship, Pearson is only for linear relationships. When does Pearson break down? Pearson breaks down when there's what issues? I have no idea what's going on. You guys are cracking me up in the chat. What breaks down Pearson? Heteroscedasticity. Nice job, Keanu, right there. Nonlinear breaks it down. One more. Non-monotonic, heteroscedasticity, outliers. These are all issues right here. If there's outliers, if there's heteroscedastic, these are all issues. So we're going to have another one coming up here. Let's see if we know how to do the next one. But this really is the only instance when we use Pearson. It needs to be linear, not have outliers, not have heteroscedasticity. And we talked about that at the end of class today. So we did a really good coverage of that. But these are good practice reviews. If you're getting a lot of these questions, then you are on track for the test. I have literally taken test questions and put it in this Kahoot. So when would we compare means and medians? That's a good question. So Mike right there, when would we compare means and medians? When would we? What kind of data would we have to have? So we'd have to have a what? So when would we compare means and medians? The y would have to be quantitative, and the x would have to be what? People are on the right track with what decisions we'd have to make, but the data would have to be a quantitative y and a categorical x. And then you'd have, like, let's say we're comparing the grades of freshmen, sophomores, juniors, and seniors. Does that make sense? The x variable here is freshman, sophomore, junior, senior, which is categorical. And then the y variable is grade. So if you think about side-by-side box plots, you would have the y variable, which is quantitative, and then the x variable breaking it up into groups. So you can compare the mean of freshmen to the mean of sophomores to the mean of juniors to the mean of seniors, if the data is normal, as people are saying. Or you can compare the median of all the groups if the data is skewed. And we'll know this by a QQ plot. So when we compare means and medians, you'd be looking at categorical x, quantitative y. These are big notes you should be taking right now. When we look at means and medians, you're comparing a categorical x and a quantitative y. So you're understanding data that way. This sort of data is what kind of data? So you can put it in the chat. We're not talking about the plot here, but this kind of data with Spearman and Pearson, where we talk about linear or monotonic relationships between two variables, is when both variables are what? Quantitative data. You're right, David, you're right. So this is for two quantitative variables. So you have to have two quantitative variables to talk about a linear relationship or a monotonic. So mean when the data is normal, right, Cody? Yep. So if we're comparing multiple groups, if the groups have normal data, we'll compare means, and if the groups have skewed or outliers, we'll compare medians. Excellent work right there. Yep, you'll be able to watch this anytime. You'll be able to see Epic Fox, but Champion Duck. You know what, Epic Fox or Epic Octopus? Champion Duck. You can't beat Champion Duck. I mean, come on. It's in the name. Champion Duck, you're my new favorite. Let's see Champion Duck win this game. Here we go. Question number 8. What is the lowest possible p-value? Be quick on the buzzer. I know a lot of people are going to know this. Don't break my heart here. And this should be a gimme question. I hope it is. I hope. I don't want to see more than 2 people miss this. If you're in the gym working out, take a quick look at your phone and be like, I know the lowest possible p-value. I got this. Lowest possible p-value. I know it. You know it. Lowest possible p-value is 0. That's all right. That's all right. That's all right. We got a few people. So p-values are the probability. Timothy, you crack me up, man. The p-value is the probability of our results or results more extreme happening by random chance variation, given that the null is true. You don't have to memorize that. But when you think about it, it's a probability. Just the first part of it. The p-value is the probability. So probabilities are contained in the interval 0 to 1, where 0 means it can never happen and 1 means it must happen. So p-values can be as low as 0 or be as high as 1. And theoretically, a p-value probably can't really be 0 theoretically, even though we can estimate it to be 0, because if something occurs, it is possible. And then thus, we would have to assign a probability greater than 0 because we observed it occurring. So fun kind of p-value theory, but in general, p-values are contained in the interval 0 to 1, including 0 and 1. That's got it. Champion Duck, I knew I was right to bet on you. Now destroy Radiant Dragon. Sorry, Radiant Dragon. Champion Duck, you got this. Let's see this happen. We're gonna play a little. Here we go with the next question. Let's do this. True or false? Correlation implies causation. Correlation implies causation. Oof. I put some of the gimme questions on here. I put some hard questions. I put some gimme questions. If 2 people get this wrong, it's going to hurt. It's going to hurt. 2 people get this wrong, it's really going to hurt. I got to watch out. I'm going to have a real heart attack. There are questions like this on the test. 3, no. It's like 3 people banded together and they were like, yeah, let's do that. Let's do that for Brian. Messing with me. Oh my gosh. Correlation does not imply causation, and this is something that drives me nuts. Is people will see p-value. I mean, correlations as high as like 0.99. They'll be like, well, I mean, that's almost 1. It's almost near perfect. And they'll be like, well, it's super high. And it's like, well, if you have 2 data points, if you just have 2 data points, they'll always have a correlation of 1 or -1 if they have any sort of slope to the line. So you can get very high correlations by random chance. And just even beyond them being by random chance, it doesn't imply a causal relationship between the two variables. There can be lurking variables. There can be, what is it called? Spurious correlations. So correlations that just kind of happen by random chance, but still are kind of low. So correlation does not imply causation. A lurking variable would be something like, let's say we're trying to explain somebody's, let's explain my favorite classic one is the amount of TVs you own and how long you live, which has a correlation that's positive. So the more TVs you own, the longer you live. So what's the lurking variable there? Probably. We can't say we know it's the lurking variable, but it kind of makes sense because when we control for it, it makes the relationship go away. Wealth, exactly. So people who have more money buy more TVs. People who have money live longer. And it's not like say, oh, if you have money, you will live longer. No, it's the general trend in the relationship is that the more money you have, the longer you live. The more money you have, the more TVs you own. Thus, we see people with more TVs living longer, but it's not TVs making them live longer. So that's a good example, my favorite example of lurking variables. And of course, we have kind of spurious correlations with Nicolas Cage and the movies he's in and people drowning in swimming pools. Fun topics. But you see this correlation that's pretty much by random chance that the more movies Nicolas Cage is in, the more people are dying in swimming pools. Not the bees. And you know exactly what we're talking about right there. But that relationship right there is moreover by random chance and not, it's just kind of, you can get a p-value that's low just by random chance. It's the Tyler Vergen, I think his name sounds like something like some Muppet talk right there, like Swedish chef. So, oh my gosh, Champion Duck, you got 2 more tries. I'm just kidding, I won't put too much pressure on you. It's an excellent job right here. Everyone's doing great. I'm rooting for you all. I have no idea who's who, so don't worry. Let's continue on to the next question. Let's see. The model used as the starting point to compute the total sums of squares error is the what? I thought it was going to break. This model, hint, has no knowledge. This model has no x's. This model has no knowledge. It's very, very new to the world. It doesn't know much. I tried to write answers here that would trick people. I'm going to feel honored if I catch 6 people. It's funny, if you hear a word a ton of times, you're like, well, that's what it is. It's the model with no knowledge. It's the naive model. Ooh, we got quite a few people. It's naive. It knows nothing. So when you think it's Jon Snow, it's the I should have put Jon Snow model, but everyone would have clicked that for fun. And we're like, heck yeah, Jon Snow model. Just forget Game of Thrones last season. I mean, second to last season was awesome. Oh no, Joseph. So it is the Jon Snow model. It knows nothing. It has no x's in there, and it computes the total sums of squares, which is the starting off for the variation, the amount of variation that exists when we begin our computations. So the naive model has no x's. You should have a note. The naive model helps us compute the total variation that exists. It has no x's in it. It is just the mean of y. That's a really excellent note, which I don't think I included enough on the test. But the naive model uses the mean of y as the prediction. So think about this. Make a naive model for the height of a person. What's your naive model for the height of a person? Like, what would you predict if I said, predict the height of someone? What would you predict? The random person, just predict their height. What's the naive model suggest, probably? Be a little afraid if people put like 6'8". I'll be like, what in the world? I wouldn't go 5'4". I wouldn't go 5'6" seems decent. 5'8", 5'6". I'd go in that range. Because what are these values you're giving me with 5'6", 5'7", 5'8"? I think that's about right there, because I think the average for women is like 5'5". I think the average for men is 5'10". And so if we go between this, we're kind of doing the average for all people, right? And so there we go. Joseph, excellent work right there. So 5'7" seems about right. So the average height for all people, if I said predict, and you see we're not using males or females here, we're just saying predict the height for people. So the naive model would predict this person's 5'7", this person's 5'7", this person's 5'7". It doesn't use anything like the person's weight. But if I said, sorry, Colin, if we were to say someone weighs 200 pounds, how tall would you predict they are? Versus someone who weighs 100 pounds. So we have someone who weighs 200 pounds, someone who weighs 100 pounds. Who would you predict is taller? Now you're making a regression model here. Now you're making a model that uses X to explain Y, because we're going to say for the people who are taller, we'd expect them to, for the people who weigh more, we expect them to be taller. So that's got all of that right there. Let's continue on to the next question. Ooh, Champion Duck. I said I was rooting for everyone. I lied. I'm rooting for Champion Duck. You knew it all along. Super Dingo is kind of cool too. Super Dingo, you can hang out here on the leaderboard. I'm cool with you, Super Dingo. Let's do this. Just sounds. I had a super dog growing up. Super Dingo sounds super cool. So here we go. If there was a super dog, you would instantly win. Which of the following is not a condition for regression? If it ever says super dog on there, I don't care what place that person's in. I will root for them the whole game. They'll just because that's the name of my first dog, super dog. And so what here is not a condition for regression? What here is not a condition for regression? Oh, sorry, Classy Hair. Of course, Classy Hair. Classy Hair is great too. I didn't give any hints. Hopefully everyone's got this. Random. We have that the model is linear, that it's well explained by a line. We have that there's an equal spread of the points around the regression model. And we have the normality of the residuals, which these are important conditions to know and important to be able to understand the output. And there will be some output on this coming up later. So we have the linearity of the model. A line goes through the data. We have the normality of the residuals, that the residuals are well explained by a normal curve, and the equal spread, which says that we should have equal spread of the residuals throughout the model. Excellent work. How's my duck doing? Duck! It's 5 points. Classy Hair. Did you do that on purpose? Alex, we need to have a talk here. You know Champion Duck's my favorite. I'm just saying. Alex, you're fine, Classy Hair. Keep it up. Keep it up. Wasn't me. Oh, you're saying not Classy Hair. Okay, good. Good, we're cool. We're good. We're good. I love it all caps. Continuing on, let's do number 12. Number 12 is true or false. Residuals should be independent. What does it mean to be independent? Mess with me here. What does it mean for things to be independent? It means knowing one residual would not give you information about another residual. Knowing one residual does not give you information about another residual. And we covered this in both classes where we talked about kind of a pattern that goes like this. Do we want this? Do we want there to be patterns in the residual? Because if they're dependent, oh, I hope I selected the right one. Oh, I'm going to freak out if I got the wrong one. Woo! Good. If they are independent, there's no pattern. So if they're independent, there won't be certain types of patterns, I should say. I guess dependent patterns will make nonlinear stuff. But you want the residuals to be independent of each other and just random normal. So I know one of the conditions said random back there, but if they're normally distributed, they'll also be under the random normal. So, oh man, everyone's disliking the true false. But remember, these are questions that could appear. Big hints right here for the test. Big hints right here for the test. So definitely check it out right here. And there's a lot of questions that can be mixed up. So I'd be writing these down, and the video is available for viewing later. So next question, who's in the lead? Ooh, is it tied leaderboard? Some people might want it to be the test. Some people might want it to be the test. I love the stock photos. There's some chickens here in the stock photo coming up, I think. Will it be this question? Let's find out. Good job, Cody. Great job. Good luck, Champion Duck. Let's find out if they win. What is the uncertainty in the slope? You might have to look closely, but hopefully you can see the output. I know it's a little small, but look for the uncertainty in the slope and then click the one that says that is the uncertainty in the slope. I know it's a little small, but I wanted a lot of numbers to be on the screen because this is the way the test looks. So squint in at your screen, find the value of the uncertainty in the slope, and let's give some hints while people are thinking about this. Anytime you hear uncertainty, you should think standard error. But be careful, there's 3 standard errors on the screen. There are 3 wow. I am impressed. That's some good responses right there. That is good response. We did cover this today in class, but that's some good responses. The uncertainty in the intercept is this value. The uncertainty in the slope is this value. And this is the uncertainty in the residuals, also known as the typical miss the model makes. Sorry, Timothy. So this is the uncertainty in the residual, in the intercept, uncertainty in the slope, uncertainty in the residuals. Is everyone on track with this? That standard error just means uncertainty. And when you're talking about different ones right here, you have uncertainty in the intercept, uncertainty in the estimate of the slope, and uncertainty in the residuals. So just remember, standard error is uncertainty. Continuing on, Glad Wolf. Who did they take off the leaderboard? I don't know. Maybe they'll come back, maybe they'll make a return. Let's find out here with the next question. What is the typical miss the model makes? Boom, I want to see some quick answers on this. What is the typical miss the model makes? This is also on your take home. So if you're doing the take home, you're like, wait, typical miss? How do I find the typical miss? Where's this in the output? So after this question, you will know where to look for the typical miss the model makes. And when you think about interpreting this, it would be when we predict the meat weight of an abalone, we would expect to miss on average by about this much. And I think it's in pounds, like how many pounds of meat we get off the abalone. So when we predict the meat weight of an abalone, we typically miss by about 0.05 pounds. It's not a percent. Please remember, we don't have an interpretation one on the test of this, but this is not a percent. It's the amount we typically miss by. So it's saying when we predict the meat weight of the abalone, because that's the y variable, we typically miss the prediction of meat weight by about this amount. Now, you don't want to say we do miss it by this amount. This is just how much we typically miss by. It's like, well, on average, it's about this. So this is the typical miss. Other words, nice job, Brennan. Of course, you know this stuff. You got this. Stay strong. Be like, I got this. Typical miss. That's the residual standard error, also known as the root mean squared error. So the residual standard error is the root mean squared error, which is just the mean error when you remove the root and the square. Think root mean squared error. The root and the square cancel, and you're left with mean error. So this right here is the root mean square error, just another synonymous word for it. Continuing on, how my octopus is doing. Wait a minute. Something's missing from the leaderboard. I can't look at this leaderboard anymore. I'm looking away this whole I can't look. This is too much. You just excited badge or glad wolf, you go away. Let's see what happens here with question number 15. What percent of the variation in y is explained by the variation in x? David, don't you be saying that. Don't you be saying that, David. Don't you be saying that. That was the wrong button. What percent of the variation in y is explained by the variation in x? So this would be something percent of the variation in meat weight is explained by the variation in diameter of an abalone. So it would be 77% of the variation in meat weight is explained by the variation in diameter. Great job. Only tricked a few people with this one. That's the one I thought would get people. Make sure you understand that the r squared right here is it's a percent. So when you talk about the percent of variation, you times it by 100. So r squared can range between 0 and 1. That's a decent note to have too. There's only one interpretation. Maybe we'll be seeing something kind of related to that here in a moment. There's only one interpretation thing on the test. So this is the percent of variation in y explained by the variation x. So 77% of the variation in meat weight of an abalone is explained by the variation in the diameter. The adjusted r squared won't be on the test. It's right behind my head right here. It's right under my nose, literally under my nose. The adjusted r squared is, and it's not on this test, but the adjusted r squared is a much fairer representation of the r squared after we adjust for how many variables are in the model. So the adjusted r squared is always lower than r squared. You can see it's just barely lower, and it won't be on this test. So the adjusted r squared, which is not r squared, it's r squared adjusted for how many variables are in the model. So the more variables we put in the model, the lower it gets, at least if we're doing bad. Worse models will have worse adjusted r squared, adjusted r squareds. So you don't need to know adjusted r squared. We'll be talking about it on Thursday, I believe, but it's adjusted for how many variables are in the model. So it makes more sense with the what. What kind of models would make more sense to talk about adjusting for how many variables are in the model? So if we have a model where we adjust for how many variables are in the model, it makes sense to do that if we have a what type of model. 1,000 points, who knows first? Multiple, Lucas, great job, exactly. When we have a multiple regression, yes, I love all 1,000 points, all those multiple regressions. That's when we'll adjust the r squared for how many variables are in the model, because the more x's we have, the higher the r squared goes. So we'll make an adjustment for how many variables are in the model. It's a much fairer assessment because multiple models have an unfair advantage because they have more variables. So we will adjust. We might be seeing some more output. Where's Duck? Where's Duck at? Let's find out. What is the correct start to the interpretation of the slope? I need to get out of the way. So what is the correct interpretation of the slope? One of these should jump out to you, and then I will interpret the slope. I will interpret the slope after this question properly. Take a huge note. Duck, where you at? Where are you at, Duck? At a fine restaurant. Ooh, We got more people with the 201 interpretation. Do not put this on this is in red for a reason. Do not put this on your test. If it's decent, you might get 1 out of 3 points. Do not write this. Does anyone have any idea how to interpret this? This is diameter in inches, and it is the meat weight. So we're predicting the meat weight, and it's a 1-inch diameter. And it's the pound of the pounds we get off it. He's flown south for the winter. So it'd be 2 abalones that differ in their diameter by 1 inch. We don't have to say the other was identical because it's not multiple, but 2 abalones that differ in their diameter by 1 inch are expected to differ in their meat weight by 1.09 pounds, where the abalone that has a bigger diameter is expected to have more meat weight. Once again, to repeat, 2 abalones that differ in their diameter by 1 inch are expected to differ in their meat weight by 1.09 pounds, where the abalone that has a larger diameter is expected to have more meat weight. It's apparently a fine delicatessen fish or something. People were looking it up during class and they're like, apparently this is very expensive. So there's a lot of money to be made in this. Yeah, maybe if I save up, I could buy a house or get a fine dinner. So I'll have to tell Chelsea, I'll say, we're spending all the money on a dinner. That is adult decisions right there. That is, I don't know. It's maybe it'll be the most amazing thing ever. Probably not. Oh my gosh. Epic Octopus. All the money. It sounds sad, right? Epic Octopus has been dethroned. Classy hair and Radiant Dragon. Some old school people here from the past. Blast from the past. Let's see who's going to win right here. What is the margin of error for the diameter estimate? Uh-oh. We've got a confidence interval right here. What is the margin of error? Any ideas on the margin of error? Any ideas? Sometimes I worry I clicked the wrong answer. Like I have a strategy. When I input answers, I always put the right one in the same spot I put in the top left corner. So that way I put the right one in, and then I don't worry about clicking wrong answers. So the margin of error is going to be half the length of the interval. Let's hope Brian can do his math properly. He did. So the margin of error is half the length of the interval. So this interval goes from 1.06 to 1.12, and the margin of error is half the length of the interval. Does that make sense to everybody? The margin of error is half the length of the interval. So this interval goes from 1.06 to 1.12. I wanted the math to be a little bit easy here. And so the length of the interval is 0.06. So this is the length of the interval. This is half the length of the interval. This is the length of the interval. This is half the length of the interval. So the margin of error is 1/2 the length of the interval. So since it's 0.06 length, margin of error 0.03. That is the margin of error. Is this interval statistically significant? Yes or no? I'm going to ask 2 questions here. And the second one's going to be a trick question. Hint. Is the interval statistically significant? Yes. Why? It is statistically significant because when we try to talk about the slope, we want to see if the slope does not contain 0. So technically it is greater than 0, which is true for why it's statistically significant, but 0 is not included. It does not contain 0 for the estimate of the slope. Is the interval conclusive? Be very careful on how you answer this. I didn't put this type of question on the test. Is this interval conclusive? Well, be careful. This is a bad question. The answer would be that does not apply to this interval. So this is not a p-value interval. When we do p-value intervals, we'd be talking about does the interval contain 0.05, which tells us whether or not we're conclusive on the interval being significant. We did this at the end. So everyone, there's the end of today's class, we reviewed this a lot, and hopefully we'll put in timestamps later tonight. There are 35 questions on this exam, 35 questions, and the interpretation one's worth 3 points. The interpretation one is worth 3 points. So, good stuff right there. Continuing on. Oh my gosh, the leaderboard is getting a crazy mix-up. If the interval, so Shuli, great question right there. I think I still have it up. 2 seconds. Boop. So here, I was making the output for this. If the interval right here, so we can all see the screen. I think you might even be seeing later questions. When you make your confidence intervals right here, if the interval right here does not contain 0, then when we look at the summary, the p-value will be what for the slope? So for the slope, since it does not contain 0, since the slope does not contain 0, the p-value for the slope coefficient must be what? So this is, we're saying we don't think the slope is 0. We think the slope is between 1.06 to 1.12. It has to be less than 0.05. So when you look here, the p-value for the slope is definitely less than 0.05. Now, the other thing people often get confused with this, and it's all right, it is confusing. We're looking at this variable today, is plot too large. No. Let's go ahead and look at this from class day. This interval right here, people often get confused with this output. These intervals are intervals trying to estimate the what. These intervals are trying to estimate the what. So these are not the same intervals that you see right. Oh, let me show this one first. These intervals. Oh, no, Alan. Oh, that's all right. Good job, Alan, for the p-value. And so these are for p-values. And is this interval conclusive or not conclusive? Is this interval right here conclusive or not conclusive? Is this interval conclusive or not conclusive? It is definitely what? It is definitely conclusive because the p-value, the interval is completely below 0.05. And you see it even gives you this output right here saying if 0.05 is in the range, increase the permutations to get a smaller interval, which might not contain 0.05. So conclusive because conclusive because it does not contain 0.05. Let's bring back that Kahoot song. Sorry about that right there, Brendan. So let's bring back that Kahoot song. Oh, no. Next question. The intercept can have no meaningful interpretation. True or false? I tricked you right there. It's like, next question. The intercept can have no meaningful interpretation. So if you go back to the last question with the EX3 abalone, the EX3 abalone could be something like, we would expect abalones that have a diameter of 0 to have a mean weight of something like negative 0.1. I can't remember if it was negative, but we could pretend. But for abalones that have a diameter of 0, we'd expect them to have a mean weight of negative 0.1. And the answer is it can have no meaningful interpretation. Ooh, tricked a lot of people there. One of my favorite models, as people know, is the height weight model. It's just such a simple model to kind of talk about. And so let's bring up data survey 10. And we go here with height and weight. And what are we talking about for this model if we interpret the intercept? When we interpret the intercept right here, the intercept of this model is going to be for individuals that have a weight of 0, we would expect them on average to have a height of 56 inches. For individuals that have a weight of 0, we'd expect them on average to have a height of 56.34 inches. No, yeah, definitely. So there are times that the intercept has no meaningful interpretation, and that's really prevalent in multiple regression, because if you have multiple regression, which we can easily make this a multiple by putting in GPA, then it would be for individuals that have a GPA of 0 and a weight of 0, and then you could do something like, I think we have desired weight. Yep. So now it's people who weigh 0, who want to weigh 0, who have a GPA of 0. So for individuals who have a weight of 0, who want to weigh 0, who have a GPA of 0, we'd expect them on average to be 52.6 inches tall. So you notice in the multiple world, we're saying even more things are 0, and we're saying what we'd expect if all the x's are equal to 0 for these individuals. And since it's 0 is like a unique value a lot of times, and a value that a lot of things can't be 0, like your height, your weight can't be 0. Height is the predicted variable, but the weights can't be 0, and I don't think anyone wants to weigh 0. Like, someone could put that down, but I'd be like, yeah, we need to talk about that. That's not really possible. So here we go. Next question. Who's in the lead? Bold Griffin. Where's Duck at? Where's Duck? Come back from winter. It's now summer, Duck. Question 19. How many tests are failed? Ooh, some output. This is one of those questions I hope people get pretty quickly. How many tests are failed? I have my fingers crossed. I had the wrong answer for this one when I was making it. I do think I changed it. I put the numbers in 0, 1, 2, 3 because I was just putting in those numbers. And then I realized I needed to put 3, which is the right answer. Oh, no. Pretty good, pretty good. 3 tests are failed. The reason here is that the null is that we are what for all the conditions. And you see the linearity, equal spread, and normality. The null is what for all the conditions. For every condition, the null is that we are what for these conditions. All conditions have a null that we are what for them. Like, you could just say the null for linearity is what? All conditions have a null of what? Well, kind of. But if you were to say, we'd start by believing linearity is what? We'd start by believing linearity is good till we have evidence it's bad. And this is evidence right here, linearity is bad. And these are one test for linearity because the diameter is the model, so it's one test. We'd start by believing equal spread is good, and we'd start by believing normality is good. So we fail linearity, there's problems with linearity, we fail equal spread, and we fail normality. If you're wondering how this looks, this is the output that we have right here. I think I used this output or very similar. So what you would do next is you would see if the sample size is greater than 25 since we failed some of the tests. We do have a sample size greater than 25. So after you fail a test, if you fail tests, you need to check the sample size. Sample size greater than 25, continue on. If the sample size is less than 25, you stop. And once you see that you have enough sample size to look at the plots, you look at the plots, and this definitely has linearity problems. It definitely has equal spread problems. And that's where you look for linearity and equal spread. Linearity and equal spread are in this plot. And then the normality of residuals is in this. And that's bad, but this is bad like dropping $5 on the ground. This is bad like dropping $100 on the ground. So, and then walking away, of course. But there's a magnitude, like this is bad, it's bad. And then this is just ridiculous. So remember those steps because I just gave away the answer to the last question. Who's going to win the game here? Remember, prizes for first and second. Email me if you get in first and second. Send a screenshot of it. Radiant Dragon just running away with it. My gosh, you'd think I'd put this up. Radiant Dragon, great job. I am impressed. Just run away. I'm going to be interested to see who Radiant Dragon was. Excited Badger, Classy Hera, Epic Octopus, Bold Griffin. Who will win? Be quick. Here we go. After we fail a test, what is the next step? After we fail a test. No hints. I gave it away earlier. If you fail a test, what do you do? Ooh. Radiant Dragon won it, right? Wait, the Octopus is leading. So did Radiant Dragon miss an early one and then just charge into the lead? Good work. So remember, listen to what if you review. So if the tests are less than, yes, exactly, Abby. Yep. If the tests are less than 0.05, you fail them. So in this, you fail all the tests. But do remember, so Abby, here's a big thing that people unfortunately misuse. They say, oh, if the p-value is less than 0.05, we fail the test. But that doesn't apply to all p-values. These are only the check normality tests. So when you're checking the normality, if the normality checks have p-values below 0.05, you fail the test. But what does this p-value mean right here? Who can help us remember? Does this mean we fail a test, or what does the p-value mean right here? What does the p-value mean right here? This p-value, which is the same as this p-value, means what? Who can help us interpret what this p-value means? Because it doesn't mean we failed a test. Well, it is statistically significant, but what is statistically significant? You are correct, Lucas. What is statistically significant? And statistically significant does mean unlikely by random chance, but what specifically was unlikely by random chance? The model. The model is statistically significant. This one is the model is statistically significant, and that means that the model explains variation we would not expect it to do by random chance, and this means the what of the model, which is the model. That means the what of the model is statistically significant. The sample size is, I'll go right back to that. Good question right there, Caleb. That means the slope. Do we really care about this one? That means the what is statistically significant. It means the intercept's probably not equal to 0. We have good evidence that the intercept is not 0. We don't care about the intercept because the intercept is pretty much an arbitrary value. What we care about is the slope, which is the XY relationship. So we don't really pass or fail the sample size. So this is a confusing thing. I hope it doesn't cause confusion, let me say. So you don't really pass or fail the sample size. You just kind of continue. If you were to have a very small sample size, you would just stop and you would say, I failed my tests, and then I don't have enough sample size to continue. So you don't really pass or fail the sample size. You just kind of stop. You say, well, since we failed the test and we don't have a large enough sample size to check the diagnostic plots, we'd stop. Good question right there, Caleb. And the intercept, I think it was statistically significant. The intercept is statistically significant. Both the intercept and the slope are statistically significant, but sorry, intercept, no one cares about you. And really great review, everybody. Awesome review. It's going to be close who wins this. Well, we know who won, I think. But here we go. Turn up that music. Excited Badger. Great job. Second place by 8 points, Classy Hair. And Radiant Dragon only missing one question. Amazing job. Was it Keanu? Was that you? Or were you Classy Hair jumping into the lead there at the end? So great job. Radiant, which one were you? If you're Classy Hair, that's awesome. Or, I mean, because that's so close. Radiant Dragon, great job, Kiana. You were Classy Hair, awesome job. After all. Excellent work. You know what? Excited Badger, let's do a $5 Amazon gift card. So Excited Badger, email me. I think I can do $5 Amazons. I think they'll let me do that. So yeah, so no, Lucas, if you're Excited Badger, $5. So 20, 10, and 5. Email me those results. No, excited, but you were doing great. You were doing great, Andrew. You won a great time and a great review, and I'm really proud of everybody. Good results. 19 out of 20 is amazing. Some trick questions on there, but great job. Use this to review. Ask questions if you have them. Let me know. Champion Duck, awesome work. I'm gonna play us out with some music here. Let's play some Mega Man. Any prizes for 11? 11's pretty good. There was like 40 people playing. Got some Mega Man. Classic Mega Man 2. Let's go to space right here. With that, it is time, everybody. Email me those questions. Work on the assignment. Work on the take-home. Let me know if you have any questions. Stat Nation, goodbye, everybody. Bye.